Hi guys, so some people said they didn't really understand the second con video, so I just wanted to take a look at some of that information. So one of the really cool sources that's out there is this Nobel Prize cell cycle game. So actually you can go to this website if you just Google Nobel Prize and then cell cycle, so those parts of the URL should get you to this page. Once you're here, we'll hit enter. Whoops. Okay. So it's a simulation. In this simulation, we're pretending that we are workers within the body of this individual. So this is the skin tissue. And here we're going to see that in this simulation, one of the cells dies. Okay, so when one of the cells dies, there's an indication that something is abnormal to the other cells that will trigger one of them to divide. So as we go, it kind of runs us through a little review of the cell cycle. So starting with G1, okay, then S, then G2, and then M. And we are going to take a look at the roles of the CDK and the cyclin in checking the cell. So we're going into this control station. Okay, so we'll go in. Perfect. We are taking the role of the CDK and cyclin in order to make sure that everything is okay within the cell and just to direct the division of this skin cell in order to replace the missing cell. So we see now that the cell is missing, okay? New cells are required, and okay, come on. Perfect. So now it's asking us, well, what needs to happen in order for this cell to divide? So we're assuming it was just going about its business, probably actually in the G0 stage, so it wasn't growing and it wasn't reproducing. So then for it to divide, the first thing that needs to happen if we're looking at our cell cycle is G1 or cell growth. So we click cell growth. Okay, if you get something wrong, I mean, it just tells you got it wrong. Okay, so we say, okay, it's growing, increasing in size so that it can fill that gap for the missing cell. And now we have a checkpoint. So this is the real job of the CDK and the cyclin, is just to make sure that everything is functioning normally. So we'll check the size. So it's like doing the scan here to make sure the size is good. Okay, so it says it's big enough to continue on. And then here, this one's saying that we're checking the genetic material at this point too, just to make sure it's normal. So perfect. I don't know if that was supposed to be words. I don't think so. So now that the cell is big enough and we check to make sure the DNA is normal, okay, so you know, the real big check at the end of G1 is to make sure that the size of the cell is normal. So according to the simulation, it's checking both, but typically we say that the end of G1, we check to see that the size is normal. Then we're entering our next phase. So it says what needs to happen next. Well, we need the synthesis or chromosome duplication, so we click there. So then we see, if you notice, the chromosomes actually doubled. Okay, so we made a copy of all the information that was in there. So we had 4 pieces of information, and now we have 8 pieces of information. Okay, but this chromosome or this sister chromatid and the one next to it are exact copies. Okay, so they're exact copies of each other. So now what needs to happen? So we're entering now G2. So we need to have some more cell growth. So we click that. Okay, so we see getting bigger, getting bigger, getting bigger. Now we're hitting a checkpoint. So to make sure that everything's normal before the cell divides, there's another checkpoint embedded in G2. So we're going to see first, okay, is the genetic material duplicated and is it correct? Okay. So this is the most important part of this phase, because if we don't check the DNA, remember, once the cell divides, it'll be now spreading into more than one cell. Okay. Cell size, are we good with the size of the cell? Okay, so continuing to scan. Perfect. And then is all the genetic material intact? So it's not damaged, not falling apart. Okay, so if we look here, there's actually damage on one piece of the genetic information. So now we have to try to repair it. So that's the point of scanning. So we scan just to make sure that if there's errors, they're repaired at the correct point in time. Okay, perfect. So now we see everything is normal after we repaired the genetic information on the one sister chromatin. And now we're entering our next phase. So now we need, let's see, well, we don't want cell destruction, so we might destroy the cell actually if it couldn't be repaired, but it is fine now. So now we're going to enter chromosome separation. All right, so we're getting our genetic material, so they're lining up, this is metaphase, so lining up in the middle. Okay, so we have the two copies of the information right next to each other, and then we're going to, okay, make sure that they're connectedly attached to the spindle. So this is another little checkpoint that occurs in mitosis, just to make sure that the DNA is going to migrate where it needs to migrate. Okay, perfect. So checkpoint cleared. Wait, what happened? Oh, cell growth. Oh, sorry, cell division. I'm sorry. Dividing the cell. I was confused because I thought our chromosomes hadn't separated yet since they were both right there. But we went through the process, okay? So we took our original cell, we fixed any problems we had, we checked for growth, and then we had two identical, so genetically identical cells in the end. So perfect. This is exactly what was supposed to happen. Remember, when damage occurs, it should be corrected. If it can't be corrected, then we destroy the cell just to make sure the damage doesn't spread. So this is a good thing to look at. I'm also going to post a little bit of a review through a different type of screencast, and you can take a look at that as well. So I actually really like this if you kind of want to play around with it. I think it's kind of fun, but I already walked you through it, so I hope I didn't ruin it too much. But it's a really good resource. Let's see, where are we? So I will see you next class. Thank you.